Hello, so today we will be discussing about lifetime distribution, survival function, and some of their properties. So to start, we will denote x to be the age, and then we want to know how many more years that does this person has before he or she dies. Okay? We will write it as t of x or tx. So this is what we call the future lifetime. So again, this is just asking how many more years does this person has before that person will die. So for example, a person age 50 dies at age 70. So his age is 50 and the future lifetime is 20 because he had 20 more years before he died. Now, if you combine x or his age plus his future lifetime tx, this is just the age of death or at death. So this is just very intuitive because this is his age and tx is the remaining time he has. Note that tx is continuous valued and also a random variable. Now, we want to know what is the probability that the person age x will die within t years. So we will denote it as fx of t, where x is the age and t is the time we want for that person to die within. So, mathematically speaking, okay, fx of t is the probability that we want him to die within t years. So that person's lifetime or his future lifetime must be less than t because we want him to die within t years. So when we write it on a timetable, so this is time 0. Let's say this is the person's age and this is person at age x plus t. We want his future lifetime to be less than t. So the person's age of death must be within here. So this be age x plus tx. We want tx to be less than t, so his age of death must be right here. Okay? Now, let's ask the opposite. What is the probability that the person age x will survive after t years? So we will denote it as sx of t. Fx of t is also, we can call it as the lifetime distribution for us. Sx of t, we will call it as the survival function. Okay? So, as for the survival function, it's just asking the opposite. We want to know the probability that the person will live after t years. So, that person's lifetime or his future lifetime should be greater than or equal to t. And then, when we write it on a timetable, so this is 0, this is the person's current age, this is the person at age x plus t. We want his future lifetime to be greater than t. Okay? So, the person should live greater than x plus t. So, the person's age of death should be around here, for example. So we are finding this region for Sx of t, whilst for Fx of t, it is within x and x plus t. Now, what we can say that for a person age x, for a person age x within t years, the person can only live or survive. Okay? For example, in this timetable, okay, so in this timetable, this is, let's say, the future lifetime of the person. This person has only two outcomes. He can only live or die. Okay? So for example, so we can say, yun nga, ulit. Okay, now we know that a person's the per- at the okay, we know that a person age X can only have two outcomes at any time. He can only live or die, right? In this case, time t, at the time t, the person can there's only two outcomes. The person can die within t years or survive after t years. So what we can say is fx of t plus sx of t is surely to happen because we know that one of these is for sure to happen. So their probability must be equal to 1. So this is one of the most important properties that we should know. Okay, so now we've established these properties and their mathematical definition. Now we will now derive now we will derive a formula. Okay, now we will derive a formula that will relate to okay, now we will relate the random variable tx and t0 to derive a new formula. So when we say tx, this is the future lifetime of a person age x, whilst t0 is the future lifetime of a newborn person. Okay? So when we say, so when we go back to the lifetime distribution, so when we say the probability of tx less than t, when we write it again in the timetable, so 0, x, x plus t, we want the probability that his future lifetime is only less than t. So the person's age of death must lie here. Okay? Now, we want to use the random variables tx and t0 to make this same timetable. So when we say T0, the probability of T0 is less than x plus t, we are just saying, let me scroll down, when we say T0 is less than x plus t, it's just saying that the future lifetime of a newborn person must be from 0 to x plus t. So the person's future lifetime or the person's age of death must be between here. Notice, compared to the earlier timetable, we have a region between 0 and x. So to remove it, we will create a condition to remove that region. So to do that, let's write the condition. The probability of t0 is less than x plus t given that the future lifetime of the person already exceeds or greater than x already. So we know that t0 is already greater than x, but remember that it must be less than x plus t. So when we write it in the timetable, the person's age of death must lie here. Okay? So now we see that these two are already equal. So let's now focus on this equation. Let me just delete everything. Okay, so we've already established this. Sorry, we've already established this to be equal to fx of t. Okay? And then now, we will use the formula for the conditional probability that the probability of A given B is equal to the probability of A intersection B all over probability of B. Now, applying this, we will have the probability, let's write this again, probability of T0 as an x plus t given that T0 is already greater than x is equal to the probability of T0 is less than x plus t intersection T0 greater than x all over the probability T0 greater than x. Okay? Now, let's focus on this equation. Okay? Let's write this here. Okay. Now, when we say, let's first focus on the numerator. So the probability of T0 less than x plus t intersection T0 greater than x. So let's write this in a timetable. 0 x plus t. We want to find the intersection between these two. So the intersection of, let's use a different color. So this part, T0 less than x plus t, is just saying the person's age of death must be within here. Whilst T0 greater than x is saying the person's age of death must be within here. Okay, so what is their intersection? We can see that their intersection can be seen here. Okay, so let me rewrite. So their intersection x plus t can be seen in this part. So we can write this as the probability of t0 is greater than x but is less than x plus t. Now, we can rewrite the whole equation. So our starting equation can be written as the probability of x less than t0. T0 is greater than x but is less than x plus t, all over the probability of t0 greater than x. Okay? But then again, how can we write this? Okay? We know that the numerator has a timetable of this structure. We can write this as the probability that t0 is less than x plus t minus let me just minus the probability of t0 less than x. Okay, let me just fix this. All over probability of t0 is greater than x. Now, to those having a hard time understanding, let me explain it again. Okay, so we've established this, the left hand side, and then let me just remove this. We know that the numerator is written as this. And then when we try to create the time diagram for this part, it's just saying, so 0x x plus t. So when we write this probability, so t0 is less than x plus t. So the person's age of death must be here. And when we write the probability of t0 is less than x, the person's age of death must be less than here. Okay, so when we minus these two, so when we minus them, what we will have remaining is this part, which is just the same. Okay, I hope that is clear for everyone. So let me just remove this. Okay, so now, what does this tells us? Oops. What does this tells us? P of t0 is less than x plus t. This tells us what is the future lifetime. What is the probability that the person age x will die within x plus t years? We can use the definition of the lifetime distribution. So we can write this or denote this as f of his current age is 0 and the probability of him dying within x plus t years, so x plus t. Whilst for probability of t0 less than x is just asking what is the probability that the person age 0 will die within x years. So it's just f0 of x. So now we can write this whole equation. Remember, everything here is just equal to fx of t. Okay, so fx of t is equal to here, and note, and we will denote it in terms of f of x, so it will be f0 x plus t, which is this one, minus f of 0 of x all over, oh, I haven't defined this yet. So when we say probability of t0 greater than x, saying what is the probability that his future lifetime or the person will live after x years? So the person will live. So it is just the survival function, person age x living after x years. So this will be over s0 of x. Now we've established a new property regarding fx of t. So now fx of t is just f0 of x of t, x plus t minus f0 of x all over s0 of x. Now, to extend this, we can use the property earlier that sx of t plus fx of t is just equal to 1. Therefore, fx of t is equal to 1 minus sx of t. Now let's do it. So fx of t will just be 1 minus sx of t is equal to f0 of x plus t is just equal to 1 minus s0 x plus t minus 1 minus s0 of x all over s0 of x. So what will happen is that this will become minus and this will become plus. So this will be s0 of x minus s0 of x plus t all over s0 of x. Okay, now let's fix it more. So we will isolate sx of t. So sx of t is equal to 1 minus s0 of x minus s0 of x plus t over s0 of x. And then we can write 1 as s0 of x over s0 of x. So s0 of x over s0 of x minus s0 of x. Okay, let's just write this below. So this will just be equal to s0 of x over s0 of x minus s0 of x minus s0 of x plus t all over s0 of x. So this will become negative s0 of x, then this will become plus. So s0 of x minus s0 of x will cancel out, and what will remain is s0 of x plus t all over s0 of x. So to reiterate, sx of t is just equal to s0 x plus t over s0 of x, and we can also write it as s S0 of x plus t is just equal to S0 of x times Sx plus t, Sx of t. So now we've derived this equation. So what this tells us that the person at age x, the probability of him surviving after x plus t years is just equal to the product of him surviving at least x years times the probability of a person age x surviving t years. So it's like decomposing the age and multiplying them all together. Okay, now to generalize this better, let's write Sx t plus u. So this will just be Sx x plus t plus u all over S0x. This is just still the same. We just added another more years. So it becomes this equation. And then we will multiply them by, so we will multiply them by S0 x plus t over S0 x plus t. So what will happen? It will become S0 x plus t over S0 x times S0 x plus t plus u over S0 x plus t. Okay, so first, this first term, remember, it is just the same as this. Okay, so we can just write it as Sx of t, while for this next term, it is just the same as this, but the difference is we added t, so it will be S0 of, oops, so this will be S x plus t of u. So if you didn't understand, again, we have the property of Sx of t is equal to S0 x plus t S0 of x, right? So if we write Sx t plus u, so this will just become, oops, sorry. So if we try to make it, let's say the person is already at age x plus t, and then we want him to survive at least u years, it will just be S0 of combined age, so x plus t plus u over S0, his current age, x plus t, which is just the same as here. So now we have created a general form for the survival function. Okay, so let's first wrap up what we've learned. We've learned these denotions, and then we've learned the important Sx of t plus u is equal to Sx of t times x plus t of u. We've also learned that f0 of x is, oops, wrong, fx of t is equal to f0 of x plus t minus 0 of x over s0 of, is it x? I'm sorry, I have to look back, yeah, of x. So this is what we've learned together, and I hope we can remember this. So these are some very important notations and also some very important properties that will be very important in more topics. So thank you for watching.